Welcome to Unit 3, Lesson 4. OMG. We're starting the sine function today, diving deep. This is almost like the start of trigonometry. I'm freaking out, man. I love it. I love it, and hopefully you will too. The whole point behind developing a like, I'm not going to say love, for trigonometry is to understand it. Once you understand it, it doesn't become as fearsome, okay? It becomes more manageable. And then you're like, oh, no, this is cool. That's okay. It's cool. That's cool. All right, so let's start lesson 4, which specifically deals with the sine function. All right, so we have a unit circle here. And in order to kind of understand the sine function and the graph, let's try and figure out, or let's try to make a connection with where the graph of the sine function comes from. All right, and we're going to do that based on things we've already gone over, and hopefully you either already know, I've taught them, or you're beginning to become comfortable with yourself. So first of all, on the unit circle, you should remember that at any point, okay, first of all, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, then we come back to a full circle, 360 degrees. And the unit circle has a radius of 1. So any coordinate, and I'll do this in green, this is the coordinate 1, 0. Okay, that's my x and that's my y. And this coordinate here, all right, is 0, 1. That's my x, that's my y. This coordinate here is -1, 0. That's my x, that's my y. And this point down here, about a douche, is 0, -1. That's my x, that's my y. All right. So if we remember, there's that little hash crossfire thing right there, craziness. Let me move that. Anyways, we should know that we don't have to use reference angles if they're quadrantal, I don't even know how to say that word. I'm going to be honest with you. I'm not much of an Englisher, a mathematics person. So any angle that's 90-degree increments, 90, 180, 270, or 360, anything that falls right on one of the axes, we don't have to use a reference angle because we can figure out the sine and cosine of that angle simply by knowing that the sine function, that's the y value. Remember? So the sine of 0 degrees is the y coordinate at 0, which is 0. The sine of 90 degrees is the y coordinate, which is 1. The sine of 180 degrees is the y coordinate, which is 0. And the sine of 270, again, the y coordinate, is -1. And then when we come back to 360, it's the same thing as 0, okay? So what I'm going to do is I'm going to take those values, all right? So the sine of 0 and 360 is 0. So I come down here. The sine, that's the y coordinate. The sine of 0 is 0. The sine of 360 is 0. Let's look at the sine of 90. The sine of 90 is 1. So I come down here. The sine of 90 is 1. The sine of 180, 0. And the sine of 270, it's -1. All right? So now we have established, if these were coordinates, okay, on an axis, this is my x value, this is my y value, as far as graphing the sine curve, not the unit circle, but the sine curve. I'm going to actually look at this table, all right, and I'm going to say that my x-axis is my degree, theta, and the y-axis is the value of the sine of theta, okay? So what I'm going to do, you'll notice I have 0 degrees, and I'm going to go all the way out here to 360. Half of 360 is my 180. Half of 180 is my 90. And then I go 3/4 of the way, that's 270. All right? So there you go. Those are the degrees that I have here. Okay, I just plotted them on my x-axis for my sine curve. All right. Now, how about purple? At 0 degrees, my y value is 0, so that's going to kind of be right at the origin. And when I say kind of be, it is going to be right at the origin. The sine at 90 degrees is 1. All right, so I need to put some y values here. I'm going to put the y value 1. Here's the y value 0. Here's the y value -1. All right, so at 90, we're up here at 1. That's what I just graphed here. At 180 degrees, we're back to 0. It's a 0. Okay. At 270, we go down to -1. That's down here, badadoosh. And at 360, we go back. It's a 0 again. Now, sine and cosine, trig is never a straight line. They are always curves. You heard me mention a few moments ago the sine curve. All right? And when we draw this, we need to draw it as a curve. I should not. Okay, what I'm about to draw in green, you don't do. It is not straight lines. That is bad. That's a no-no. Okay? So, what I want to do, and now you can do this, all right? I'll do this in red so it pops. It curves kind of like parabolas downward, then upward, boom. Congratulations. That is one sine curve. And of course, I don't know if you can see that. It does connect there. I know I drew it in 2 pieces. But that's a sine curve. That is one complete cycle of a sine curve right there. And now we know where that comes from. That comes from the values that we get from the unit circle. That's how we figure out the sine of, and I'm going to do this again, highlighter, blue. The sine of 0 degrees is 0. So I look here, and I have a coordinate at 0, 0. Boom. I go back here. The sine at 90 degrees is 1. So I have a coordinate at 90 degrees. I'm up here at 1. Boom. Okay? And so forth. It follows that same circle. That's where this graph comes from. And now you know. And look at, you just graphed one cycle of sine. I like the smiley face. It's a nice little touch. It's good stuff. All right, let's talk about some ways we can see our equation written, which is going to help us create the graphs of these things, all right? So the first thing I'd like to point out is you are going to have the sine of some variable x, okay? So you're going to have the sine of x, but then you're going to have these 3 letters. You might have a number. I called it a letter because it's a variable. A is going to be a number. That's going to represent amplitude, okay? Then we're going to have, we could have some number in front of the xb. That's going to represent my frequency. And then we could possibly have, I'll go with this, some number on the outside, plus or minus d. That's going to represent my midline. Okay, notice I didn't highlight the period. My period will never be in the equation. I can figure out my period using the values of that equation, but my period will never be in there. This is going to be the amplitude, frequency, and midline. Okay, so let's discuss what all these mean. Okay, yellow for yellow here. Amplitude, that's how high and low, or there, you can consider them the mins and maxes. The curve, the sine curve, goes from your midline. Okay, you're like, from your midline? What's that? We'll get to midline. Okay. In fact, we can do midline next. All right. So, orange and orange. Now, the D value, that's your midline. And I should do this. Amplitude was obviously your A value in your equation. Okay? So, go back here, orange for orange. My midline, that represents the middle of your sine curve. And I'm going to go back to the curve we just drew. All right? Bam, right here. This graph way down here, my midline, this is the middle. It's kind of like where the zeros are. You see that? You see where my 360, 180, and 90 are? That's the exact middle, okay? That is known, the midline. If I wanted the equation of the midline, I would say it's y equals 0. That's this dashed line here, okay? That's the middle of my graph. My amplitude would be 1 because I go up 1 to the highest point, and I go down 1 to the lowest point, okay? So my amplitude would be 1. My midline here is y equals 0, okay? Now, frequency. Frequency, that is the B here. Now, I don't know why they make amplitude A and frequency B. I don't know why they don't make frequency F. If they were just going to do A, B, and the next thing would be C, the midline should be C, shouldn't it? But they make that D, I don't know. They make things difficult for you on purpose. They don't. I don't know who came up with it, but look it. If you want to call it A and F or whatever and M, that's fine. Okay? I think the reason they don't use F for frequency is because we use functions, f of x, and they don't want you getting confused. Not like they didn't confuse you already. All right? So, frequency, that is the number of sine curves. Okay, I call that's going to be like your S's. That's a sine curve. The number of sine curves in 360 degrees, or if it's in radians, in 2 pi. Okay, so it's the number of sine curves in 360 degrees or in 2 pi. All right. So again, if we go back to our original graph, here's 360 degrees right here. Here's 360. Here's where it starts. I only see one S in 360 degrees. So my frequency is 1. All right? That's all that means, the frequency. Is how many curves. If my frequency was 2, I should have 2 S's, or 2 S curves, 2 sine curves in 360 degrees. Now we're on to the period. The period is the length. Yeah, I should put the T before the H. Oh, that's just disgusting. It is the length of one cycle, which I mean one sine curve, 1S. All right. But how do I get that if it's not in the equation? I take 360 and divide it by my frequency. Or if it's in radians, I take 2 pi and divide it by my frequency. All right? Now, frequency and period have a special relationship. Here's a little side note. If I have the period and need the frequency, I can do the same thing. My frequency would equal 360 divided by the period. I'll call period P. Or if it's in radians, it's 3, yep, I'll be okay. If it's in radians, it would be 2 pi divided by the period. So this right here is period, is 360 or 2 pi divided by frequency. If you want to make these F's for frequency, you can. And likewise, if you have period and want to find frequency, I can just switch my F and P, and it would still work. Okay? So this is a nice little tidbit to have in the back pocket there, in the old back pocket. All right? So if you were to see an equation, you might see y equals 2 sine of 4x plus 5. Okay, you should know 5 is the midline, 4 is the frequency, 2 is your amplitude. And you can figure out the period by taking 360 and dividing it by whatever the frequency is. So let's practice this. Let's get some practice under our old belts here. All right. The first thing I'm going to do is, this is really, and you don't have to rewrite this. I'm just trying to show you. It's 2 sine. It's really 1x if it's not written there. And I'm really adding nothing to the back here. You don't have to rewrite this. Okay. I just want to show you. Here's my amplitude. I'm going to call frequency midline. Okay. Now, before I graph this, I like to do a couple of things. I write this off to the side because I'm a perfectionist, and this helps me connect everything. My amplitude, I know I'm using capital A as little a, is 2. My frequency is 1, which means my period is 360 divided by my frequency. So it's 360 divided by 1. My period is 360. And my midline, well, that's y equals 0. Okay? So I'm going to take this information I just jotted down right here, and I'm going to graph this bad boy. I'm going to sketch it. So I'm going to go like this, bang. I know that one cycle, a period is one cycle of my S curve. Okay? A period is one cycle of my S curve. I know one cycle is going to go to 360 degrees. 360, half of that is 180, half of that is 90, then I go to 0. Now look at whatever value goes here. Notice I started with 360. I want half of that, it's 180. Half of 180 is 90. If I add these two values, that will always give me this third value here. Because the numbers might not always be nice and neat, like 90 and 180. Okay? But if I add those two terms, that's just a little something that I like to do when I got to figure out this junk. It gives me this third term. Okay? Now, my amplitude is 2. That means I'm going up to 2 this time and down to -2. It is no longer -1 and 1. And here's 0 on the y-axis. That is my midline. Okay? So again, the way I graph this is I know that sine starts at 0, it ends at 0, and the middle is 0. Then it goes up 1, and well, it goes up in between the first two, and down in between. So I always start by doing the first, the last, and the middle, because I know those are zeros. So the first one is at the midline, the last one is at the midline, and the middle, the midline. I know in between my first two, it goes up to my amplitude 2. And then in between the last two dots, it goes down to -2. So now, bam, that's a sine curve. You just graphed y equals 2 sine of x. All right? One thing I would like to mention about this right here, okay? My amplitude, it doesn't matter if A is positive or negative, okay? My amplitude, you can just consider that whatever, the absolute value of A. If it's positive or negative, look at that. I combined negative and amplitude and said negitude. Whatever A is, if it's positive 3, my amplitude is 3. If it's -3, my amplitude is still 3. So what happens if A is negative? If A is negative, it is a vertical flip. That means instead of going up, then down like that sign, it will start going down, then go up. So it's a vertical flip. Okay? Think about a parabola. If it's negative, instead of opening up, it flips and opens down, right? The same thing with sine. A negative will just flip the way it is. All right? And now we're on to example 2, and just perfect, there's a negative sign here. Okay? So that's the same thing as saying -1 sine of 1x. You don't have to rewrite it. I am. My amplitude is 1. My frequency is 1. Okay? My period, well, that's 360 divided by my frequency. So it's 360 divided by 1. That's 360. And my midline is still nothing in the back here. So it's +0. Still at y equals 0. Okay? But notice, it is negative. So if it's negative, I always say there's a vertical flip. And I draw it like this. It's going to look like that. It's not going to start going up, but it's going to start going down. Sine is my S. Remember that. So it's my S curve. I know the period is 360, so I know it should end at 360 degrees. Half of that, 180. Half of that, 90. 90 plus 180 gives me my 270. And again, we have 0. All right. My amplitude is 1, so it's going to go up to 1, down to -1, and my midline is 0. Okay. So I know sine, whether it's positive or negative, it always starts at the midline, it ends the midline, which is 0, and in the middle, 0. But instead of going up, it's negated, so it's going to start going down first. Then this at 270, instead of going down, it's flipped and it's going up, okay? And that's what the negation does. It flips it. So now you have, boom, you just have y equals negative sine of x. And there you go. We graphed it. So based on the graph, what is the value of y? So they want to know our y. When x is 3 pi over 2. 3 pi over 2 is 270 degrees, okay? So what's the value here? The y value is a positive 1. So y equals 1. Not too bad. So in essence, what you just solved is the negative sine of 3 pi over 2. You just figured that out just by knowing the graph. Example 3. Okay, now we have some numbers in here. Good. My amplitude is 2. My frequency is also 2. My period, okay, is 360 divided by my frequency. That's 360 divided by 2. That's 180. The length of one cycle is no longer 360. It is 180. All right? So my midline, it's still y equals 0 because it's like adding 0 to the back here. Okay, there's nothing. All right? So let's do this. Let's go ahead and graph this. All right, let's draw our axis here. Now, this curve, one curve, and that's what they want us to sketch, one cycle, it ends at 180 degrees. All right? So I'm going to say, I'm going to put 180 here for a reason. Closer to the what's half of 180? It's 90. What's half of 90? It's 45. If I add 45 and 90, I get 135, and here's 0. Okay? Now, my amplitude is 2, so it goes 2, -2, here's 0, it's my midline. Once again, I know that sine starts at the midline, it ends at the midline, and in the middle, it's also the midline. Now, this isn't negative. Okay, it's a positive sine function, so it's going to go up in between the first two dots and down in between the next two dots. So that's what one cycle looks like. But there's a reason, and I want to stress the frequency here. If I were to go out another 180 degrees, look, from here to here, that's 180 degrees, right? That's the length of one cycle. If I graphed 2 cycles, okay, the frequency is 2. So in 360 degrees, I should see 2. That's what my frequency means. So if I were to graph this at 360 degrees, okay, half of that's 270, and this is going up by 45. You see that? So this would be 225. This would be 315. I'm going to do this in a different color. Now my next one would start at 180, and one cycle is 180 degrees, right? So from 180, going out another 180 degrees would take me to 360. So I start at the midline, I end at the midline, and the middle is the midline. In between my first 2 dots, I go up 2. In between the last 2 dots, I go down 2. So look, it would continue. So if I wanted to graph this 360 degrees, I should see 2 sine curves. That's what that number tells me. The frequency is 2. How many curves in 360 degrees? 2. Here they are. Here's the first one. Here's the second one. All right? For our sake, they only wanted 1. So that's why I only did the 180. Okay? But I really wanted to stress to you what that frequency means. All right? So let's take a look at some of these questions. what is the maximum height of 2 sine of 2 theta? And what is the value of theta at the maximum height? Okay, so I'm only looking for our purposes. We're graphing one cycle of this, right? Okay, what's the maximum height? The maximum height is a height of 2. 2 is the max height. What's the value of theta? What is my angle when it hits the highest? 45 degrees. X height at 45 degrees, okay? Or if you want that in radians, that ends up being pi over 4. So now, if I were to graph 2 sine of 2 theta from 0 to 2 pi, this is 360 degrees. How many cycles would you see? 2. That's what the frequency is. That's what we just flipping did. Let's see if I can do this. Can I get it back? How far can I go? There you go. How many cycles would I see if I graph this at 360 degrees? I would clearly see 2 cycles because that's the frequency. All right? Cool beans. All right, on to the next one. 4, graph one cycle of f of x equals -3 sine of 3 theta. Okay, so my amplitude is 3. My frequency is 3. My period is 360 divided by my frequency. So that's 120. That's the length of one cycle. My midline hasn't changed, so it's still y equals 0. But it is negative. So I have a vertical flip, and I remind myself it starts down, then up. Okay? So let's graph this. Very, very simple. I'm going out to 120 degrees. Half of 120 is 60. Half of 60 is 30. 30 plus 60 gets me my 90. And I have 0 here. My midline is at y equals 0. It will go to positive 3. 1, 2. It will go to -3. Okay? And I'm going to start graphing this right now. Keeping in mind that it'll be a vertical flip. So it starts at the midline. It ends at the midline. And in the middle is the midline. Instead of going up first, because I have a negative in front of my amplitude, it should go down first. And then it goes up. So I actually have a graph that looks like that. That's y equals -3 sine of 3 theta. Okay? Not too bad. So state the range. The range of one cycle. Domain is all my x values. Range would be all my y values. Well, the highest it goes is a 3, and the lowest it goes is a -3. So it would be from -3 to 3. It doesn't go anywhere outside that boundary for the y-axis. Okay? Now, I like this next question. It's exactly the same thing, except the midline is +2. Okay? So I'm going to take, my amplitude is still 3. My frequency is still 3. My period, I still take 360 and divide it by 3, which is 120. Boom. My midline is now y equals 2. Okay? And this is still a vertical flip, which means it's going to go down, then up. All right? So, okay, we are still going 120 degrees. That's the end. Half of that is still 60. Half of that is still 30. If I add 30 and 60, that's still 90. Here's 0 degrees. Now, normally, 0, I would go 1, 2, 3. Okay, -1, -2, -3. But keep in mind, my midline, or middle, is now at 2. Okay, this is my midline, which means if my amplitude is 3, I need to go up 3 from 2. So I need to go to 5. And I go down 3 from 2. That brings me to -1. So my min and max, my amplitude, that adjustment is going to be made from the midline. So if my amplitude's 3, I'm going to add 3. My max point will be 5. I would subtract 3, and that brings me to -1. So those are my highs and lows. Okay? So when I graph this function, I know it starts the midline, which is 2 now. It ends the midline, which is at 2. And in the middle is the midline, which is at 2. Okay. Now this is negative, so it's going to be vertically flipped. So in between my first 2 dots, I'm going down 3 to -1. And then in between the last 2 dots, I go up 3. So I go from 2 to 5. So basically, it looks still a curve. Bam. So what did my midline do? The middle was the x-axis, or y equals 0, and it just moved up 2. So this was right here. It went up to 3. Okay, it went up to 3 and down to -3. All right, but I took all those dots and moved them up 2 spots. Put the douche right there. That's what the midline does. It actually moves it up or down. And we move that whole graph up 2. Okay? So now you're kind of getting a feel for what it does. Ooh, example 5. Fancy. Looks like there's a fraction involved. All right? So let's do this. Let's graph one cycle of y equals 5, x over 2. Okay, so 5 sine of x over 2 minus 3. I hope you know this is 1x over 2, right? So I'm going to rewrite that as saying 5 sine of 1/2 x minus 3. Amplitude, frequency, midline. My amplitude is 5. My frequency is 1/2, which means my period is 360 divided by 1/2. No, it's not 180. Dividing by 1/2 is like multiplying by 2. 720. That is the length of one cycle. And my midline is at y equals -3. So I need to move down 3. My amplitude's 5. So if I add 5, that brings me to 2. If I subtract 5, that brings me to -8. So my midline is going to be at -3. My maximum is going to be at 2. And my minimum is going to be at -8. I need to make that adjustment of amplitude of 5 from the midline, up and down from the midline. So let's do this. And I'm going to put this up here because I need to go further down to -8, then up. 720 degrees, that's how long one cycle is. Half of that, 360. Half of that, 180. 180 and 360, believe it or not, it's 540. And here's 0. Okay. Now my midline, -1, -2, is at -3, -4, -5, -6, -7, -8. That's my lowest point. And 1, 2, that's my highest point. Okay, I just did this. Midline, lowest point, highest point. Now I'm going to graph sine. And I know it starts at the midline, which is -3. It ends at the midline. And in the middle is at the midline. Then, because this is positive, it's not negative, it's going to start going up. It's going to go up to 2 and down to -8. All right, and now I just do my curves. Am I going through that dot? Yeah, curves, curves, boom. My, what a fancy, great graph you drew. And it's right. Okay, good job. Fractions freak people out, but that's okay. All right, here's another one. If you want to pause it and do it on your own, go nuts. I'm about to do it now. That's like saying 3 sine of 1/2. Oh, pi. Look what they did to me. Theta. My amplitude is 3. My frequency is pi over 2. My period, now because they gave me pi over 2, Okay, this is obviously in radians. My period is either 360 divided by the frequency, or my period is 2 pi divided by the frequency, pi over 2. Okay, well, that's the same thing as saying 2 pi times 2 over pi. And if I do that, okay, if I divide by a fraction, it's like multiplying by the reciprocal of it. The pi's cancel. 2 times 2 is 4. The length of one cycle is 4. There is no change in the midline. That's still y equals 0, because it's like plus 0 back here. So let's graph this. 4. That's fine. That's what my period is. So that's what I'm going to say. It's 4. Half of 4 is 2. Half of 2 is 1. The last time I checked, 1 plus 2 was still 3. Here's 0. And my amplitude, okay, my midline is at 0. 1, 2, positive 3. 1, 2, negative 3. Sine, and this is very redundant, starts at the midline, it ends at the midline, in the middle of the midline. And since this is positive, it's going to go up 3 first, then it's going to go down to negative 3, just like that. And we're going to go douche, 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 boom. Fantastique. Good stuff. I'm proud of you. Okay, now they're not giving us an equation to sketch. They're saying sketch one cycle of a sine curve with the amplitude of 1/3, a period of pi. Write the equation of this curve. Let's stop here because there's going to be some explanation. I hate to do 2 videos for this lesson, but I'm going to. Okay, so we're going to stop here. We're going to have a part 2 coming up where we pick up writing the equation, and that'll be fine, so we could take our time doing it. Not that it's complicated, it's just working backward. But seeing how this is the first time we're doing it, I don't want to get crazy and try and rush through it. All right, see you next time. Unit 3, Lesson 4, Part 2. See ya.